On October 24th, astronomers listening in radio picked up a strange, tightly focused signal from the interstellar object 3I Atlas as it drifted through our solar system. At first, it looked like noise. Then the chemistry appeared. Hydroxyl radicals. Water, broken apart under starlight, leaving its ghostly fingerprints in the data. That part we expected. Comets do that. What no one expected was where the signal seemed to come from. The same patch of sky as the infamous WOW signal of 1977. And that's only the beginning. 3I Atlas is already keeping researchers awake at night. Subtle deviations in its trajectory that shouldn't be there. At least 8 documented anomalies in its behaviour. And a detection window so narrow that statistically, we should have missed it completely. Tonight, in this late-night exploration, we're going to slow everything down and walk through what was detected, why it matters, and how this one mysterious visitor may quietly rewrite what we thought we knew about interstellar objects, and maybe about who or what might be out there. If you enjoy drifting through deep space mysteries like this, you're welcome to gently tap like so more wanderers can find this video. And in the comments, tell me where you're tuning in from, what time it is there right now, and what you think this new signal really means. Settle in. Let's listen to what 3I Atlas just told us. It starts with almost nothing. Just a soft hiss in the headphones, the kind of gentle, endless static that sounds a bit like distant rain. The observatory control room is half lit, pools of warm light on the consoles, most of the room fading into shadow. Outside, the night is cold and clear. Above the dome, the sky is a black ocean, scattered with distant stars that have been shining quietly for billions of years. Most nights nothing surprising happens. The instruments listen. The computers log data. The screens crawl with graphs and numbers that look almost identical to yesterday's graphs and numbers. Space, most of the time, is calm and indifferent. It speaks in slow changes and long silences. But on this particular night, buried deep in that silence, something changes. At first, it doesn't even feel important. A junior researcher sipping lukewarm coffee notices a small, narrow rise on a spectrum that should be flat. Just a thin, sharp peak on a long, quiet line. They frown, scroll back, check the calibration logs. Maybe it's interference from Earth. Maybe it's the satellite that always ruins the cleanest data. Maybe it's nothing. They flag it anyway. The observatory software sets a tiny marker in the river of numbers, the way you might fold one corner of a page in a book. They run a quick background check. Known satellites, known radio sources, previous interference events. One by one, the usual suspects fall away. The computers are patient and impartial. They don't get excited. They just cross-reference, compare, eliminate. The researcher feels their heart rate pick up just a little. They widen the window around the signal, more data streams in. The static is still there, the same soft hiss. But now there's clearly something else riding on top of it. A faint, precise structure, like a single piano note emerging from a noisy crowd. The clock on the wall moves quietly past midnight. Someone else is called over to look, then another person. Chairs scrape softly on the floor. There's no dramatic music, no one shouting, just a quiet shift in the room's atmosphere. The way the air feels when everyone suddenly realizes they might be seeing something that has never been seen before. The signal is narrow, focused. It occupies a specific slice of frequency space, not spread out like common interference. It comes from a particular direction in the sky, right where the instruments are pointed, following the predicted path of a faint, fast-moving visitor, 3I Atlas. They watch the graph dance. The peak rises, holds, and then slowly begins to fade. The whole event lasts only a short while, a brief flare in a sea of sameness. If the telescope had been pointed a little away, if the timing had been slightly off, if the servers had been in maintenance mode, no one would have noticed. It would have been just one more whisper lost in an infinite ocean. But this time, they were listening. Recordings are saved. Timestamps are checked again and again. Someone mutters the observation time under their breath, as if saying it out loud will make it more real. Another researcher quietly opens an old catalogue, cross-referencing known natural lines at those frequencies: hydrogen, hydroxyl, familiar atomic and molecular signatures. There it is, hydroxyl radicals, a known natural tracer, water molecules, broken apart by harsh starlight, leaving behind fragments that emit at particular, well-understood radio frequencies. The chemistry is real. The numbers line up. The universe is doing what the universe does, shining, breaking, recombining, repeating. But there's still that unease, that tiny persistent feeling that something here is just off. The intensity looks a bit too organised, the profile is a bit too neat, the timing is a bit too perfect. It's as if a natural process has been placed in a frame, like a photograph, and held up for someone to see. While the computers hum and the data backs up to servers around the world, the human minds in the room drift to stranger questions. They know better than to jump to conclusions. They know how easy it is to see patterns where none exist. And yet, as the hours pass and the analysis deepens, a subtle weight settles over the control room. Outside, the telescope continues to track the sky. Somewhere, far beyond the slow-moving swirl of the planets, 3i Atlas glides through the darkness, an unremarkable speck of ice and rock by most standards, a leftover fragment from another star's story. It does not glow with engines or flash with lights. To the eye, it is just a faint smudge against a black background. And yet, for a brief moment, it has spoken in radio. The signal is confirmed, the instruments are cross-checked against others. The call goes out to additional observatories. Point here, at these coordinates, at this time. See if you can catch it too. Somewhere else on Earth, another team stares at another screen, watching for the same narrow peak. The night grows later, the coffee grows colder, but no one is really tired anymore. Because every once in a long while, the universe stops being a silent painting on the ceiling of the sky, and starts to feel like something that can answer back. This is one of those nights. And even though the data will take weeks to fully analyse, to publish, to debate, to recheck, the people in that room already know that their quiet shift has ended differently than most. A folder on a server now contains a new piece of the cosmic puzzle, tucked neatly alongside countless others. But this piece is not from our neighbourhood. It comes from a traveller between the stars. If you could float outside the observatory at that moment, gently drifting above the roof in the cool air, you'd see the dome turn toward a very small patch of sky. Just one tiny region in the vast sphere around Earth. Everywhere else, the cosmos looks the same. Patterns of stars, dark lanes of dust, occasional planets, quiet and remote. Yet in that one patch, a visitor is passing through. 3i Atlas is not bound to our sun. Its path is open, a sweeping hyperbolic curve that cuts through the solar system once and then continues onward, never to return. It has its own history, written in frozen layers and buried fractures, shaped by light from a different star long before ours ever mattered to it. Long before we gave it a name, it was already on its way. Astronomers label it 3i because it is the third known interstellar object to pass through our solar system. Before it came others, strange, fast-moving objects that didn't loop around the sun like normal comets and asteroids, but instead swooped in and rushed back out, cleaving the plane of our planets like stones skipping across a pond. To understand what makes 3i Atlas special, imagine the solar system as a kind of small, illuminated island in a vast ocean. Most of the rocks and ice that we see in our telescopes are local, born from the same original cloud that formed the sun, sculpted by the same family of planets. They follow obedient paths. They know the rules here. Interstellar objects are different. They don't belong to our island. They come from other shores, perhaps from the outer debris fields of distant stars, perhaps from ancient collisions in other planetary systems. Somewhere, long ago, a gravitational nudge or a violent encounter kicked them loose, sending them drifting into the deep dark between suns. For ages, we never knew they were there. Space is enormous, and these objects are small. A city-sized rock passing tens of millions of kilometres away is nearly invisible to our eyes. For most of human history, they came and went in complete secrecy, sliding past our world while we stared up at the stars and told stories, unaware that silent messengers were occasionally slipping by. Now, though, our instruments have become more patient, more precise. Surveys scan the sky night after night, comparing one image to the next, hunting for tiny dots that move against the background stars. A lot of them are familiar, near-Earth asteroids, ordinary comets. But every so often one appears with a path that just doesn't fit. It's moving too fast. Its orbit doesn't close. If you trace its trajectory backward, it doesn't come from the outer regions of our own solar system. It comes from somewhere else entirely. The vast, dark gulfs between the stars. That's how 3i Atlas first entered the story. At first, it was just another faint dot in a survey. A small blur that shifted slightly between exposures. Astronomers measured its position, then measured it again, then fed those numbers into models that predict orbits. The answer that came back was unmistakable. This object was not a long-lost member of our own solar family. It was a stranger. By the time anyone realised this, 3i Atlas was already inbound, falling past the outer planets on a steep, one-way plunge toward the inner solar system. The sun's gravity reached out and bent its path slightly, curving it just enough to give us a chance to see it before it vanished back into the dark. Even then, it was a challenging target. Interstellar objects tend to be small, dark and fast. They don't linger. They don't politely wait for us to be ready. Observatories around the world had to coordinate quickly, adjusting schedules, retargeting instruments, trying to gather as much data as possible in the short window before it faded below detection. From the perspective of an ordinary person on Earth, nothing seemed different. The night sky looked the same. The moon rose and set. The constellations followed their usual paths. But high above, near the edge of what our telescopes could see, 3i Atlas was slipping by, a foreign shard of rock and ice, carrying within it the memory of another star's light. If you could stand on its surface, ignoring for a moment the lack of air, the deep cold and the crushing silence, you would see a very unfamiliar sky. The sun would be just one more star among many, a bright point in a field of distant lights. The familiar constellations would be distorted, twisted into strange shapes by perspective. The Milky Way would still arch across the cosmos, but the patterns we use to navigate by eye, Orion, the Big Dipper, Scorpius, would be almost unrecognisable. On 3i Atlas, nothing in the sky would line up with human stories. For most of its existence, that was all it knew. Endless darkness, cold, and isolation between stars. No planets circling nearby, no warm glow of a close sun, just the thin radiation of the galaxy and the occasional passage through faint interstellar clouds. Then, after an unimaginable journey, our solar system came into view. From our side, it appeared simply as numbers first: detection coordinates, brightness estimates, motion vectors. From its side, if it could somehow remember, it might have felt something like a slow, gentle pull as the sun's gravity drew it in. Light grew brighter. The background stars shifted more rapidly. The specks of the outer planets glimmered faintly ahead, and as it approached, our own tools finally noticed. We gave it a designation, logged it in catalogues, pointed radio dishes and optical telescopes at it. We traced its orbit, trying to predict where it had come from and where it was going. We studied its brightness and colour, hoping to learn about its surface and composition. All this attention focused on a distant icy fragment that had never known it was being watched. 3i Atlas might be small and dim, but for scientists who study the universe, it is a treasure. Each interstellar object is like a physical sample from another planetary system, a piece of someone else's cosmic history that has wandered into our reach. By analysing its light, its chemistry and its motion, we can learn not just about the object itself, but about the conditions in the place it originally formed. Is its ice content different from our comet's? Does its dust reflect light in a different way? Does its behaviour, how it outgasses, how it reacts to sunlight, match what we expect, or does it surprise us? In the case of 3i Atlas, the surprises came quickly. Its path through the solar system didn't line up perfectly with what gravity alone would predict. Its brightening and fading patterns were a little odd. The chemistry we inferred from its emissions hinted at both familiar and slightly unusual combinations. It was, in some ways, exactly what we hoped to see, something like our own comets, but not entirely. Familiar enough to understand, different enough to remind us that other solar systems play by their own rules. And then, on that quiet night in the observatory, the story took a turn. Because 3i Atlas didn't just drift by, leaving only a faint trail of reflected sunlight in our telescopes. It left a mark in our radio instruments as well, a signal, narrow and structured, carrying the fingerprints of water broken apart by light, arriving from the direction of this interstellar traveller. The visitor between the stars had not only passed through our neighbourhood. For a brief, fragile moment, it had left behind a voice. By the time the signal truly arrived, the night at the observatory had settled into its usual rhythm. The telescope was already tracking 3i Atlas, following its predicted path across the sky with slow, mechanical precision. Inside the control room, the atmosphere was quiet and almost domestic. The soft hum of cooling fans, the occasional clink of a mug being set down, the gentle tapping of keys as someone adjusted a parameter or logged a note. On the main monitor, 3i Atlas itself wasn't much to look at, just a faint smudge on a dark background, occasionally refreshed as new data came in. The real action was hidden in numbers the eye couldn't see, streams of values scrolling down consoles, spectral lines being drawn in real time as radio waves from the sky were collected, sorted and plotted. Most of the team had seen nights like this hundreds of times. They knew the routine: point, track, record, archive. The sky is generous with data but stingy with surprises. You learn to expect long periods where nothing particularly remarkable happens. You learn to take comfort in that, the way sailors get used to the steady rise and fall of waves. But in the data pipeline, something subtle was already beginning to change. It started as a slightly odd pattern in the noise, a little ridge in the background that didn't quite match previous baselines. At first, it looked like a calibration quirk. Instruments warm and cool, electronics drift a bit. Software occasionally needs to be nudged back into line. The system, ever patient, flagged the tiny discrepancy and continued. Then, the ridge grew. One of the consoles was dedicated to a real-time spectrum display, frequency along one axis, intensity on the other. Normally, for a quiet patch of sky, it showed a gentle, uneven landscape of low-level static. Little bumps here and there, random fluctuations. But now, right around a familiar range of frequencies, a single sharp peak began to rise, like a solitary mountain in an otherwise flat plain. At first, only one person noticed. Eyes slightly glazed from hours of looking at similar graphs, they blinked, leaned in, and watched. They scrolled back a few minutes, then forward again, making sure it wasn't just a momentary glitch. The peak persisted. It trembled a bit as the noise wavered, but it didn't vanish. It held. The researcher glanced at the timestamp, the telescope's position, the current target, everything lined up. The instrument was pointed exactly where it was supposed to be pointed. No recent changes, no alarm messages, no obvious reason for the sudden and neat spike in the data. They quietly called someone else over. Soon there were 2 people watching the screen, then 3. No one raised their voice, no one made any dramatic gestures. The feeling in the room was more like the hush that falls over a library when someone opens a strange old book. That sense of something important, delicate, and not yet fully understood. For a while, they did what astronomers always do first. They tried to prove it was nothing. They checked for known sources of interference, nearby transmitters, communication satellites, aircraft, even local equipment like Wi-Fi routers, or phones that might have been left on. Lists were cross-referenced. Databases were searched. The frequencies used by common human-made signals in that direction were compared against the one on the screen. Nothing matched. The signal was narrow. That alone made it interesting. Nature tends to smear things out, spread them across a range of frequencies. Sharp, tight features are rarer and often more revealing. This one stood cleanly out of the noise. Not an enormous spike, but a clear, confident line. Someone started a separate recording just in case. In another part of the control room, a different computer was plotting the motion of 3i Atlas under gravity. A little dot followed a calculated curve, its position at each moment updated with the latest observations. The trajectory passed directly through the region of the sky the radio telescope was currently listening to. They checked the alignment again. Still perfect. Then came the next step in their quiet checklist: redundancy. If you want to trust a signal, you try to catch it with more than one ear. They shifted the telescopes pointing slightly to either side to see if the signal faded as it ought to if it was coming from that narrow patch of sky. It did. Move away, it weakens. Move back, it strengthens again. A neat, consistent behaviour that suggested a real, distant source, not some local interference creeping into the system from behind. Someone sent a quick message to a collaborating observatory in another part of the world. Depending on the timing and visibility, another telescope could try to listen in, even if only for a short interval. If they heard the same thing from the same direction, at the same frequencies, it would transform a curious blip into a serious event. The night, which had begun as routine, was now turning into a carefully choreographed dance between instruments spread across the planet. Meanwhile, the signal continued to speak. Not in words or patterns your ears could recognize, but in the measured, disciplined structure of the spectrum. At the hardware level, radio waves were being collected by an enormous dish, reflected, focused, and quietly converted into electricity. That electrical whisper travelled along cables, into receivers cooled to near absolute zero to minimize noise, then into amplifiers and digitizers. From there it became data, rows and columns of numbers, frozen snapshots of the sky's radio brightness at different frequencies and times. The software didn't know or care about mystery or drama. It just did its job: read, process, store. And in doing so, it captured the moment an interstellar visitor left its imprint on our instruments. As the minutes passed, more eyes were drawn to the screen. Someone dimmed the lights slightly, not because it was necessary, but because it felt right. The control room began to feel less like a lab and more like a small ship at sea, with everyone leaning toward the same porthole, staring out into the night, watching something glide past. They plotted the signal's strength over time. It rose, peaked, and slowly began to fall, like a tide coming in and going out. They measured its central frequency with increasing precision. They compared it to known atomic and molecular lines. Patterns began to emerge. A familiar set of numbers floated to the top of the analyses, tied to a simple but profound component of the cosmos: water. The realization moved through the room like a quiet wave. If this was what it seemed to be, they weren't just seeing some random burst of noise. They were detecting the chemical fingerprints of broken water, fragments of H2O ripped apart by light, leaving behind free radicals that glowed at specific radio frequencies: hydroxyl. Oh, the ghost of water? The team knew this kind of emission well. It appears in comets. It appears in the diffuse gas between stars. It appears wherever water molecules are destroyed and their pieces briefly shine before cold, and darkness swallow them again. It is in many ways a simple, familiar story. But here, that familiar story was being told by a very unusual narrator. This wasn't a local comet born alongside our planets. This was an interstellar traveller carrying its own ancient ice from somewhere else in the galaxy. The signal they were seeing was both ordinary and extraordinary at once. just another instance of the universe doing what it always does, and at the same time a message from a place we've never seen. Eventually the peak thinned out. The signal grew weaker as the geometry changed, as the object moved, as the conditions along the line of sight shifted, as the angle between Earth, 3i Atlas, and the Sun slowly rearranged itself. The peak did not crash or explode or suddenly vanish. It simply faded. The noise flowed back into its place. The room didn't celebrate. Astronomers rarely do, at least not right away. Instead, they got to work. The recording was checked, then backed up in multiple locations. Logs were annotated. Every setting on every instrument was documented so that later, when the fever of the moment had passed, they could retrace their steps with cool, careful attention. But beneath all that quiet professionalism, something else lingered. The feeling that, for a short while, they had been listening to a conversation they didn't fully understand. A conversation between starlight and ice, between radiation and matter, between a rogue traveller and the invisible fields that fill the galaxy. A night that had begun as ordinary had ended with a signal that would take months, even years, to fully absorb. In the days that followed, the data from that night was pulled apart and reassembled many times. Spectra were replotted at higher resolution. Background noise levels were carefully recalculated. Statistical tests were run to determine just how likely it was that such a signal could appear purely by chance. Every small bump and wiggle in the graph was examined, its reality weighed against the possibility of noise, and slowly as the analysis matured, a clearer picture emerged. The frequencies involved were not random. They lined up with well-known transitions of hydroxyl radicals, extremely specific energy jumps that occur in atoms and molecules when they interact with light. These transitions correspond to tiny changes in the way electrons and nuclei arrange themselves. When those changes happen, the particle emits or absorbs radiation at a particular wavelength. That wavelength, when stretched out into frequency space, becomes a line. To radio astronomers, the universe is filled with such lines: the signature of hydrogen at 21 centimeters, the fingerprints of carbon monoxide, ammonia, formaldehyde, and many other molecules drifting between the stars. Each line is like a note in a cosmic chord, and by listening to the pattern of notes, scientists can tell which atoms and molecules are present. Hydroxyl radicals occupy a special place in this orchestra. They're often produced when water molecules are exposed to intense ultraviolet radiation. Imagine an icy surface, perhaps the outer layers of a cometary body, slowly rotating in the light of a star. Sunlight in the ultraviolet range hits the ice and begins to break the bonds holding water molecules together. Hydrogen and oxygen separate, forming fragments. One of those fragments is OH, a molecule made of one oxygen and one hydrogen atom. It doesn't live forever. In the crowded and chaotic environment around a comet, it may collide, react, or be stripped apart further. But for a while, it exists. And in that time, under the right conditions, it can emit radio waves. Those emissions are what the telescope caught. If you imagine zooming in on the region around 3i Atlas, beyond what any camera could see, you might picture a thin, invisible envelope of gas surrounding it. As the interstellar object feels the warmth of our sun, its ice begins to sublimate. Not melt exactly, but shift directly from solid to gas in the vacuum of space. Small jets of vapor escape from cracks and pits, carrying molecules into the surrounding space. Some of those molecules are water. The further they drift from the surface, the more exposed they become to starlight. Photons from the sun slam into them, sometimes with enough energy to break their molecular bonds. The clean, simple H2O formula dissolves into a chaotic spray of fragments, individual hydrogen atoms, oxygen atoms, and hydroxyl radicals. As these fragments move through space, they rotate and vibrate. At the quantum level, each of these motions is quantized, allowed only at specific energies. When a hydroxyl radical shifts from a slightly higher energy state to a slightly lower one, it must get rid of that excess energy. One way it can do that is by emitting a photon, a tiny packet of light at a very precise frequency. Now imagine trillions upon trillions of these radicals doing this, scattered in a roughly comet-shaped cloud around 3I Atlas. Most of the time, their emissions are faint and spread out, blending into a background murmur, but when a dense enough region forms, or when the geometry between the sun, the object, and the observer is just right, the signal can become stronger, more organised, and easier to detect. From Earth, that strengthened signal appears as a bright, narrow spike in a spectrum. And because we know, from laboratory measurements and theory, exactly which frequencies hydroxyl radicals like to emit at, we can read that spike like a label. Water was here. It's important to understand how ordinary that is, and how extraordinary. On one level, it's just chemistry. The same physics that governs a glass of water on your table, or the way ice evaporates from a winter window in the sunlight, also governs the behaviour of molecules in deep space. The laws do not change out there. Hydrogen and oxygen dance to the same rules, whether they're frozen in a comet or flowing in your veins. But the context is different. In the vicinity of 3I Atlas, that chemistry is playing out in a place that doesn't belong to our solar system. The ice that is releasing those water molecules was formed somewhere else, perhaps in the cold outskirts of another star's planet-forming disk, perhaps in a region of space where conditions were slightly different from those in which our own comets were born. By studying the precise shape and strength of the hydroxyl lines, scientists can infer things about that distant history. How much water is being released? How does the line intensity change with distance from the Sun? Does the behaviour match what we see in local comets, or is it subtly different? Are there hints of other molecules mixed in, shifting the pattern in ways that standard models don't quite predict? Each small deviation is a clue. For those working with the data, the signal from 3I Atlas is like a message written in a language they understand but with a strange accent. The letters are familiar, the frequencies, the transitions, the quantum mechanics behind them. But the overall cadence feels slightly off, shaped by conditions that are not quite the same as those in our backyard. This is what makes the detection so captivating. On the surface, you could say that all we have is a line in a spectrum, a little bump in a graph that corresponds to broken water. But beneath that simple description lies the realization that we are, in some small way, sampling the chemistry of another star's environment. The hydroxyl radicals that sang to our radio telescopes did not originate here. Their parent water molecules were assembled from elements formed in ancient stellar furnaces, cooled and condensed in a different corner of the galaxy, perhaps shepherded by planets we'll never see. Then, through a long chain of gravitational accidents and cosmic nudges, that ice-bearing rock was thrown out, sent wandering, and eventually passed through our solar system, just long enough for our instruments to listen. When you think of it that way, the signal becomes more than just a spike. It becomes a ghost story. A ghost of water that once slept in darkness between the stars, now briefly illuminated by our sun, speaking in radio frequencies before fading back into silence. A ghost of other worlds, other skies, other histories, carried on a fragment of rock that will soon be gone from our view. To the people analysing the data late at night, this is the real magic. Not aliens shouting across the void, not dramatic codes hidden in the noise, but the quiet, persistent voice of physics itself, telling them that the universe is connected, that the chemistry that makes oceans and clouds and life on Earth is not confined to our home, but is scattered everywhere, even in the coldest, loneliest travellers. And as they trace the delicate, precise lines of hydroxyl in the spectrum of 3I Atlas, they are reminded that every drop of water, every molecule of breath, every wave on every ocean is part of a much larger story, one that begins in the hearts of stars, winds through comets and interstellar debris, and occasionally, just occasionally, passes close enough for us to hear it. For days after the detection, the observatories involved in the 3I Atlas observation buzzed quietly, not in the loud, cinematic way of breaking news, but in the subdued, almost reverent hum that happens when something profound is under review. The data was being verified, checked and rechecked across continents. The official confirmation hadn't been released yet, but within the small, close-knit world of radio astronomy, word travels like gravity. Silently, invisibly, but with irresistible pull. And as the details of the signal, its frequency, its timing, its coordinates, spread through private channels, one particular line in the report began to make people pause. It wasn't the hydroxyl chemistry. That was expected, even elegant in its familiarity. It wasn't the narrowness of the signal, though that was strange. It wasn't even the fact that it had come from an interstellar object, though that alone was enough to make history. It was the coordinates. When the data was cross-referenced with star maps, the signal's apparent origin in the sky corresponded, almost perfectly, with a patch of space in the constellation Sagittarius. Not a random spot, but one with a peculiar and legendary history. That patch of sky had spoken before. Back in August of 1977, a volunteer astronomer named Jerry Eman was scanning radio data from the Big Ear telescope at Ohio State University. The telescope was part of an early project to search for extraterrestrial intelligence, to listen for any sign, however faint, that we were not alone. The project had already been running for years, mostly producing static, the endless sea of random noise that fills the radio sky. And then, for 72 seconds, something extraordinary happened. A strong narrowband radio signal appeared. It was clear, structured, and unlike anything the telescope had recorded before. It wasn't a natural emission from known astronomical sources. It wasn't interference from satellites or radar. It was something else. Something that, for just over a minute, seemed to be transmitting directly from the depths of space. The signal was so striking that when Eamon circled it on the printout, he scribbled a single word in the margin. Wow! The wow signal became one of astronomy's most enduring mysteries. Decades later, no one has ever fully explained it. The telescope was fixed in place, relying on Earth's rotation to sweep the sky. So the signal was heard once and never again. Follow-up observations found nothing. Countless hypotheses were proposed. A passing comet, a reflection of Earth-based radio signals, even a distant pulsar, but none fit the data perfectly. What has haunted astronomers ever since is its silence. It came once for a single brief interval and was gone forever, like a stranger whispering your name in a crowded room, then disappearing into the noise. And now, in 2025, an interstellar object named 3I Atlas had spoken from almost the same celestial address. At first, scientists dismissed it as coincidence. Space is vast, but the sky is full of overlapping coordinates. Two signals sharing a general region doesn't mean they share a cause. But when they overlaid the positions precisely, the match was close enough to make people uncomfortable. In the history of radio astronomy, few directions in the sky carry more emotional weight than that tiny sliver of Sagittarius. It's the place where optimism and skepticism have battled for nearly half a century. To see it flare again, from a visitor that doesn't even belong to our solar system, felt like hearing an echo that took almost 50 years to return. The comparison began to spread through forums, emails, private Slack channels, and late-night discussions at observatories. Same sky region, hydroxyl line, interstellar source. The phrases repeated like an incantation. No one wanted to say the word out loud, not seriously, not yet. But the thought was there, glowing quietly at the edges of every conversation. What if the wow signal wasn't a one-time event? What if it was a beginning? For every cautious astronomer reminding the community of Occam's razor that the simplest explanation is usually the right one, there were others who couldn't ignore the symmetry. Two separate detections, nearly half a century apart, both linked to the same sky coordinates, both narrowband, both anomalous. It was as if something, or someone, out there had chosen its window carefully, speaking across decades rather than seconds. Even the skeptics admitted it was eerie. The more poetic among the scientists began to describe it differently. They said it was like lightning striking the same tree twice in an infinite forest. Others compared it to a message in a bottle, washing ashore on two different beaches centuries apart. Some wondered if 3i Atlas, travelling between star systems, might have passed through that region of the sky by design, not as a random trajectory, but as part of a longer journey that had brushed against Earth before. Of course, there are natural explanations too. Hydroxyl emissions occur all over the galaxy. Comets, molecular clouds, star-forming regions, they all produce radio signals in the same frequency range. And when an interstellar object passes through our solar system, its interaction with sunlight can easily mimic such effects. In a purely physical sense, it's chemistry and coincidence, nothing more. But there's something stubborn about human imagination when patterns begin to align. We are creatures wired to find meaning in the noise, to trace constellations out of random stars. And as the details of the 3i Atlas signal continue to circulate, more and more people felt the old thrill return. The same thrill that rippled through the scientific world in 1977, when Jerry Amon wrote his word in the margin. For those who remembered that first whisper from Sagittarius, this new one felt like the second line in a half-finished conversation. And just when the discussion was reaching a fevered pitch, new anomalies began to surface. It started with something simple, brightness fluctuations. Observers noted that 3i Atlas was brightening and dimming in ways that didn't follow the expected curve. Most comets and icy bodies grow brighter as they approach the sun, then fade smoothly as they recede. But 3i Atlas was erratic. Its light would rise, then dip, then flare again, not violently but enough to catch attention. Next came the motion. Astrometric measurements, precise position data, revealed that its trajectory wasn't perfectly gravitational. There were small deviations, gentle but measurable, as if faint jets of gas were pushing it in unpredictable directions. That can happen naturally when sublimating ice vents into space, but the pattern didn't match the usual spin dynamics seen in comets. The direction of thrusts seemed to shift irregularly, almost rhythmically. Then came the polarization anomaly. When scientists measured the polarization of a light reflected off 3i Atlas, they found it fluctuated in ways that suggested an unusually complex surface, perhaps smooth regions interspersed with highly reflective structured patches. Something about the way it scattered light seemed engineered, though that's an unscientific word no one dared write in their papers. After that, the chemical oddities emerged. Spectroscopic analysis hinted at trace elements not typically found in comets of our own solar system. There were signatures that could suggest exotic ices, or perhaps compounds formed under radiation environments different from ours. Some even speculated it might carry materials forged near a different kind of star entirely. Maybe a red dwarf, maybe something older. And then there was the spin. As astronomers modelled 3i Atlas's rotation, they found it tumbling in a peculiar way, not simply spinning about one axis, but precessing, as though its mass distribution were uneven or hollow. This wasn't proof of anything strange, but it added to the growing sense of mystery, a traveller that not only moved unpredictably but seemed to carry its own rhythm. 8 anomalies in total were logged over the first month of observation. None of them, individually, were impossible to explain. Space is chaotic. Data is noisy. Instruments can deceive. But taken together they began to form an uncomfortable pattern, the same way a set of coincidences can slowly begin to feel like a design. By this point, research teams around the world had split into 2 camps. The first camp held fast to caution. They insisted that every strange behaviour could be accounted for by the physics of ice and sunlight, the interplay of heat and motion in a fragile interstellar body. They spoke of sublimation fronts, of jet-induced torques, of non-gravitational accelerations, all normal things that only seemed uncanny because of our limited experience with visitors from other stars. The second camp, smaller but more vocal, whispered about possibilities that didn't fit within the tidy framework of cometary science. They pointed out how 3I Atlas's outgassing seemed timed, not random. How its reflective patches could, under certain angles, behave like solar sails. How the radio signal didn't drift in frequency the way natural emissions typically do, suggesting an unlikely degree of stability. These weren't wild-eyed theorists from the fringe. They were quiet professionals, well aware of the ridicule that comes from using the wrong words in the wrong order. But even they couldn't ignore the whisper at the back of their minds. What if this isn't just another rock? The debate spread beyond laboratories and into the public sphere. News outlets ran headlines like "Echoes of the WOW signal return" and "Alien probe or cosmic coincidence." The scientists cringed at the sensationalism but couldn't fully deny the fascination. After all, the data was genuinely strange. Late-night discussions began to wander into deeper territory. If 3I Atlas wasn't natural, purely as a thought experiment, then what would it be? A fragment of technology adrift between stars? A derelict probe, still reflexively emitting signals that its creators had long since forgotten? A relic of an extinct civilization, gliding silently through the dark, carrying the chemistry of its homeworld as a kind of fossilized message? The possibilities were too vast, too intoxicating to ignore. But for every speculative leap, someone else pulled the discussion back to ground. They reminded everyone that anomaly doesn't mean miracle. Science is built on patience. Most mysteries, once enough data is gathered, turn out to be ordinary and extraordinary disguise. The universe rarely hides magic behind the curtain, only more complex layers of natural law. Still, the emotional undercurrent was undeniable. There was something haunting about the timing, the sky location, the chemistry, and the deviations all stacking atop one another like the faint outlines of a story half told. It wasn't proof of intelligence, but it was a whisper that refused to fade. One astronomer put it best in a quiet interview. "Every piece of data we have so far tells us this is probably a natural phenomenon, and yet, every instinct I have says it wants to be noticed." No one knew quite what to make of that, because that's the paradox of discovery. The closer we get to the unknown, the more it begins to look like us. Curious, unpredictable, full of patterns that may or may not mean something. And as 3I Atlas continued its slow arc through the solar system, shrinking day by day in the telescopes, the arguments didn't resolve. They only deepened. For now, it remained a visitor shrouded in question marks, a traveller with 8 anomalies, a chemical voice, and a trajectory that defied easy explanation. The universe had once again handed humanity a puzzle, the kind that doesn't fit neatly into textbooks or models. And somewhere, buried in the cold noise of the data, there lingered the unspoken thought that maybe, just maybe, the WOW signal had never been alone. If you were to look at the path of 3I Atlas drawn on a clean sheet of paper, it would seem so simple at first, just a curve. Astronomers like curves, they trust them. For most objects in the solar system, you can chart their motion with almost frightening precision. Put in the mass of the sun, the positions of the planets, the initial velocity of the object, and gravity will do the rest. The numbers fall into place. Equations trace out elegant arcs and ellipses. Everything moves according to rules that have been tested for centuries. When 3I Atlas first appeared in the data, that's exactly what happened. Observers plotted its position night after night, feeding each new measurement into models that calculated its orbit. The answer that came back was clear. Not a closed loop like a planet, but an open, sweeping path. A hyperbola that would carry it past the sun once and then fling it back into the dark between the stars. A classic interstellar flyby. Quick hello, long goodbye. On the screen, the orbit looked smooth and assured, like the stroke of a calligrapher's pen. From far above the solar system, you would see a thin grey line curving inward from the direction of deep space, swooping around the sun, then bending outward again, never to return. But that was the idealised version, the version written by gravity alone. reality is always noisier. As more observations came in, small differences began to accumulate between where 3i Atlas was predicted to be and where it actually appeared in the sky. At first, the offsets were tiny, fractions of an arc-second, amounts smaller than what you could see with your eye. But the instruments weren't guessing, they were measuring very precisely, and the pattern of those measurements began to drift, slowly, steadily, away from the pure gravitational track. If you imagine placing pins along the predicted orbit, one pin for each night's expected position, and then placing tiny beads where the object actually showed up, the two lines would initially hug each other. But over weeks, the beads would start to tug away from the pins, like a thread being pulled sideways by an invisible hand. This wasn't entirely surprising. Comets and icy bodies almost always misbehave a little. They're not solid iron cannonballs obediently following Newton's laws. They're fragile, porous, and volatile. As sunlight warms them, gases trapped inside their icy crust begin to sublimate and escape. The escaping gas acts like a thruster, providing a small but continuous push. If that gas jets out more strongly in one direction than another, the comet's motion is nudged very gently off the purely gravitational path. Astronomers call these influences non-gravitational forces, and they're familiar with them. There are formulas to account for outgassing, spin, and other messy details. As long as you know roughly how active the comet is, you can tweak the model and bring the predicted path back in line with observations. With 3i Atlas, they tried exactly that. They introduced parameters to represent outgassing, simple terms at first, assuming that the venting of gas was symmetric or slowly varying. The model improved, but only partly. The beads on the thread came closer to the pins, but not all the way. There were still small deviations, tiny but persistent, that didn't quite match the standard patterns. So they refined the model again. This time they allowed for more complex behaviour. Jets of gas that turned on and off, different levels of activity at different distances from the sun, uneven distribution over the surface. They simulated an object spinning in a slightly chaotic tumble, exposing different regions of ice to sunlight at different times. The computer chewed through possibilities, adjusting the parameters in search of the best fit. The path on the screen shifted, flexing and tightening around the observational data. The beads and pins aligned more closely now. For many objects, this would have been the end of the story, an initially puzzling deviation, patiently tamed by better modelling. But even with these improvements, the orbit of 3i Atlas retained a kind of stubborn residue, small recurring discrepancies that rose and fell in a pattern no one fully liked. It was like trying to explain the movement of a leaf in the wind by only accounting for the breeze, when every now and then something else, a fingertip, a ripple in the air, a passing hand, seemed to nudge it in a different direction. These weren't dramatic cinematic course changes. They weren't sudden jumps or right-angle turns. They were more like gentle rhythmic pulses. Sometimes the object seemed to lag slightly behind the predicted path. Other times it crept ahead. The deviations formed a subtle waveform when plotted over time, not perfectly regular, but suggestive enough to raise questions. The safest explanation was still outgassing. If there were clusters of vents on specific parts of the surface, and if 3i Atlas was tumbling in a way that brought those vents into sunlight at repeating intervals, that could generate periodic pushes. Imagine a spinning garden sprinkler, but instead of water, it's tiny jets of gas shooting into space whenever a cracked, icy region rotates into sunlight. Each spurt gives the object a little tap, slowly reshaping its trajectory. Under that model, the pattern of deviations was simply the footprint of a complicated spin and a patchy surface. But another quieter question lurked at the edges of that explanation. What if the taps weren't random? What if the rhythm meant something? For generations, scientists and science fiction writers have played with the idea of spacecraft using non-gravitational forces intentionally. Solar sails catching starlight, directed jets adjusting course, subtle maneuvers designed to look almost natural. If you wanted to move through foreign planetary systems without being noticed, it would make sense to move like a comet, to blend in with the local debris. So when 3I Atlas displayed motion that looked almost like traditional outgassing, but not quite, it stirred imagination. In late-night conversations, some dynamicists confessed that the data felt like watching a drunk but deliberate walker, someone who stumbles, but always in a chosen direction. If you zoomed out far enough, the path still looked like a simple hyperbola. But up close, at fine scale, it had texture. To keep themselves honest, astronomers tried another angle: energy bookkeeping. In a gravity-only universe, the energy of 3I Atlas relative to the Sun should follow clear rules. As it falls inward, it accelerates. As it climbs back out, it slows. Non-gravitational forces add complexity, but they still have to obey conservation of energy and momentum. If gas jets are doing the pushing, there must be enough mass being lost and enough heat driving that loss to account for the observed changes in motion. So the teams took the measured deviations and asked, if gas is causing this, how much gas would need to escape? Is the observed activity, the brightening, the coma, the tail, consistent with that amount? The answer was uncomfortably uncertain. In some intervals, the calculated gas release seemed plausible. In others, the required thrust implied a level of activity that should have been more obvious in the brightness and structure of the coma. It was as though, at times, 3I Atlas moved more than its visible exhaust could convincingly justify. There are, of course, caveats. Our ability to measure faint cometary activity at interstellar speeds is still new. There may be effects we've underestimated: anisotropies in the surface, internal fractures, complex thermal behaviour that isn't easy to model. Nature has many ways to surprise us before we need to invoke anything extraordinary. Yet still, when dynamicists gathered around screens to stare at plots of residuals, those tiny, stubborn differences between model and reality, the room would grow strangely quiet. On one side of the argument stood gravity, gas, and ordinary ice. On the other stood a temptation: the idea that 3I Atlas might not be entirely passive. For now, gravity still held the louder voice. The equations, for all their imperfections, still did a good job of describing the bulk of the motion. The small deviations may eventually yield to better models the way so many mysteries have before, and yet, that whisper remained. A path that should be perfectly predictable isn't quite. A visitor that should be unremarkable isn't. And the universe, once again, is just misbehaving enough to keep us awake. Far from the screens and spreadsheets somewhere in the cold dark where 3I Atlas actually is, none of this argument exists. There is only motion. The object hurtles along its invisible rail through space, feeling the weak but steady pull of the sun fading behind it. Dust and gas trail away in a faint ghostly veil. Whatever spins and tumbles it, whatever forces have nudged its path one way or another, they are now all balanced against the emptiness pulling it back toward the interstellar night. And as its trajectory slowly frees itself from the gravity of our star, another conversation continues here on Earth. One not about where 3I Atlas is going, but about what it really is. For most scientists, the starting point is simple. Assume it's natural. The universe is old and vast. There are countless shattered worlds, endless collisions, and innumerable fragments of ice and rock drifting between stars. We've only just begun noticing them as they pass through our solar system. It would be a huge leap to assume that the third such object we've ever studied closely is somehow artificial. So they begin, as science always does, with the most conservative hypothesis. In that view, 3I Atlas is a kind of cosmic rubble, a shard chipped away from a larger body long ago. Maybe it was once part of a dwarf planet in a distant system. Maybe it was thrown out by the chaotic migrations of giant planets. Maybe it's a survivor of some ancient violent era in another star's youth. However it formed, it eventually found itself on a long lonely journey through the thin, cold medium between stars. This story fits comfortably with what we know. The chemistry, though intriguing, still lives within the realm of plausibility. the hydroxyl lines, the water decomposition, the dust, the strange but not impossible brightness patterns, all can be framed in terms of bizarre but natural physics. Unusual does not mean unnatural. A snowflake can be intricate without being designed. That's the natural comet picture. Imperfect, but familiar. In this story, the signal we detected is not a deliberate message, it's an accidental glow. The side effect of water molecules being torn apart by sunlight, nothing more. The radio emission is no more intentional than the hiss of steam from a kettle. It's just what happens when heat meets ice in vacuum under certain conditions. The non-gravitational accelerations. Those are jets of gas from subsurface ice, venting in complex ways. The erratic spin? That's what you'd expect from an irregular lump of rock tumbled and torqued over millions of years. The anomalies? Artifacts of our inexperience and our yearning to interpret every strange thing as a sign. It's a comforting explanation in its way. It allows the universe to remain vast and impersonal, governed by rules we mostly understand. We can write papers about strange interstellar comets without needing to ask uncomfortable questions about intention and meaning and intelligence. But there is another story, not the official one, not the one that appears in formal abstracts, but the one that sometimes surfaces in whispered conversations over late coffee or in quiet corners of conferences. In that version, 3i Atlas is still an interstellar object. It still carries ice and dust and the scars of ancient collisions. But it is not only debris. In this speculative story, it is a construct, perhaps a probe, perhaps a shell wrapped around something else, perhaps an artifact that has long outlived its makers. Its shape might be irregular on purpose, designed to pass for natural. Its surface might be patchy and reflective not by accident, but to harness light or disguise its true structure. Its jets, if they are jets at all, might not be purely the chaotic breath of sublimating ice, but controlled releases, tiny course corrections made to maintain a chosen path. In this story, the signal we detected is not just the voice of hydroxyl radicals, but a repurposed natural channel, a way to piggyback on natural chemistry, so that any civilization watching comets as we do might notice. No narrowband carrier beam shouting, "Here we are." Just a slight sharpening of the line, a curious steadiness in the frequency, a pattern that feels almost like language but falls just short. It's a story that fits less comfortably with what we know, but more tightly with what we dream. The idea of an object that looks like a comet but behaves just oddly enough to stand out has been floated before in theoretical papers and science fiction novels. The concept of lurkers, probes that sit quietly in stable orbits or pass through planetary systems disguised as rocks, is attractive precisely because it would be so hard to distinguish them from the background clutter. If you were an advanced civilization wanting to monitor young, noisy species without disturbing them, what better cover than the universe's own rubble? 3i Atlas, passing through our solar system, hits many of those symbolic notes. Interstellar origin, chemical signatures that draw attention, anomalous trajectory nudges, a signal detected from a sky region already infamous for one unresolved mystery. Taken individually, each of these points is flimsy as evidence. Together they form a narrative that's hard to entirely ignore, not because it's likely, but because it's haunting. Still, there is a danger in leaning too far into that story. Our brains are pattern-making machines. Give us enough noise and we will find faces, messages, portents. The human tendency to anthropomorphize, to assign intention where there is only process, is strong. Lightning looks like anger, a storm looks like a mood, a strange signal starts to look like a hello. Scientists know this. They train themselves to distrust thrills. When data seems to confirm our dearest hopes, that's when we must be most suspicious. So the discipline bends back on itself, reminding everyone, extraordinary claims require extraordinary evidence. And right now, the evidence is not extraordinary. It is intriguing. It is suggestive. It is worth staring at for long, contemplative hours. But it is not a smoking gun, not even a warm one. So a third way of thinking emerges somewhere between just a comet and alien artifact. In this middle view, 3i Atlas is still likely natural, but its existence and behaviour tell us something profound even without needing it to be engineered. It reminds us that the galaxy is not a static postcard. It is a place of continuous exchange. Fragments of one star system wander into another. Materials from worlds we will never see drift within reach of our instruments. Chemistry forged under a different sun leaves its fingerprints in our data. We too are participating in this exchange just by looking. If someday we do discover a genuinely artificial object from another civilization, it will almost certainly appear first as an anomaly, as something that looks 90% natural with a stubborn 10% that refuses to be explained. The only way we'll recognise that 10% for what it is by having spent years, decades, centuries studying countless mere comets and fragments, learning how nature behaves when it is left entirely to itself. 3i Atlas, with its puzzles and deviations, might simply be one more step in that long education. Each time we find a visitor like this, we sharpen our models. We learn to distinguish new kinds of natural weirdness from true impossibilities. We refine our sense of what normal is in the galactic context. And somewhere along the way, if the universe is kind and crowded, one of those anomalies may eventually refuse to be explained away. For now though, 3i Atlas exists in a gentle tension. To some, it is a fascinating but ultimately ordinary interstellar comet, carrying the story of another star's outskirts in its ices and dust. To others, it is a tantalizing candidate, not proof of anything artificial, but a reminder that the line between rock and artifact might be thinner than we think. Most of us, watching from the quiet of our rooms at night, fall somewhere in between. We lie there imagining both possibilities at once, a natural traveller, older than our species, passing indifferently through our solar system, and the faint, barely formed image of a messenger disguised as ice and stone, drifting silently past our little world to see if anyone is finally ready to notice. Whether it is one, the other, or something we haven't yet imagined, the result is the same. We look up more closely, we listen more carefully, we pay attention. And maybe that is the first real change 3i Atlas has brought. Not out there, but in here, in the minds that now find it harder than ever to see the night sky as empty. If you zoom out far enough, the whole drama of 3i Atlas becomes just one tiny line, sketched across the grand map of the galaxy. A single visitor, one pass through one solar system, one brief flare of radio noise, one set of anomalies, one small moment of human curiosity. From certain angles it looks like almost nothing at all, but if you tilt your perspective just a little, you begin to see how deeply this changes the way we think about our place in the universe. For most of human history we imagine the solar system as a kind of sealed neighbourhood. Our comets, our asteroids, our planets, our sun. A mostly closed story, with the occasional meteor from some nearby reservoir of rocks. It was big, but it was ours. Interstellar objects like 3i Atlas tear that boundary open. They tell us, very quietly, that our neighbourhood is not closed at all. The gravitational tides of the galaxy are always shuffling material from one star system to another. Pieces of foreign worlds are gliding through our skies unseen, unremarked, unless we happen to catch them in the thin beams of our instruments. Just knowing that is already transformative. It means that the chemistry of distant stars does not stay neatly confined around them. It wanders, it drifts, it passes through alien sunlight and into the reach of alien telescopes. Every shard of rock from another system is a physical message. This is what the universe did over there. With 3i Atlas, we're not just looking at a smudge on a screen. We're touching, with math and light, the story of a different sun. The detection of water-related chemistry, those fragile hydroxyl radicals singing in radio frequencies, deepens that shift. Water is not rare in the cosmos, but feeling its presence so clearly on an interstellar object gives that knowledge weight. It's one thing to hear, water is common out there in a textbook. It's another to say, we have measured the broken pieces of a distant system's water as they evaporated under our own sun. It's like tasting the rain of another world. Even if 3i Atlas is entirely natural, its passage tells us that the raw ingredients for oceans, atmospheres, and maybe even life itself are not locked away in isolated pockets. They roam, they mix, they cross the borders between stars. That invites new questions. How much material from other systems has already fallen onto Earth long before we had telescopes to notice? How often has our planet been dusted by the ashes of other planetary systems, by ice from other skies? Perhaps some of the atoms in our oceans have already spent time in the commi of interstellar wanderers long before humans ever named them. This discovery also changes things for radio astronomy in a quieter, but no less powerful way. For decades, the WOW signal existed like a lone ghost in the archive, a single, unexplained anomaly from an otherwise silent patch of sky. It hovered at the edge of respectability, too strong to ignore, too singular to fully embrace. Some called it the best candidate evidence we'd ever seen for extraterrestrial intelligence. Others tagged it as interesting but likely natural, then filed it away mentally as a kind of cosmic riddle. Now in that same region of sky, we have a new story. Not a neat solution, not a final answer, but a new layer. A known interstellar object. Real chemistry. Real radio emission. Real motion we can plot. The patch of sky that once held only one unsolved whisper now holds two overlapping tales. One a mysterious burst from 1977, the other a detailed multi-instrument detection from 2025. This doesn't solve the WOW signal, but it reframes it. Instead of thinking of that direction in the sky as a single isolated event, we are beginning to see it as a place where interesting things can happen, where complex radio phenomena, both natural and maybe not so natural, might occasionally line up with our gaze. It nudges us away from thinking of the WOW signal as a one-time miracle, and towards seeing it as part of a longer conversation we've only started to overhear. And beyond all the technical implications, the refined models, the improved survey strategies, the updated catalogues, there is a softer, more human way this discovery changes everything. It changes how the night feels. Before we learned to spot interstellar objects, it was easy to look up and imagine the solar system as a kind of snow globe. Stars outside, planets and comets inside, all turning in predictable loops. Now, each time you look at the sky, you can't quite shake the feeling that something from very far away might be passing quietly overhead. Something that doesn't belong to our sun at all. It might not shine, it might not signal, it might never be seen, but it could be there, slipping by in the dark, part of a slow cosmic exchange that has been going on for billions of years. In that sense, 3i Atlas doesn't just change the data, it changes our imagination. It expands the mental map we carry in our heads. It stretches the idea of here until it begins to blend with everywhere. It suggests that the universe is not made of isolated islands, but of currents, slow, ancient rivers of rock and ice and dust flowing between stars, exchanging stories without words. And somewhere in that realization, something very quiet shifts inside us too. Because if pieces of other systems can wander into ours, maybe ideas, life and meaning are not as separated as they seem either. Maybe the galaxy, at its deepest level, is not just a physical space, but a shared history. All its stars are quietly writing together, one stray fragment at a time. Now imagine you've stepped outside, far from city lights, holding all of this in mind. The sky above you is clear, or as clear as it can be where you are. The familiar constellations have already begun their slow drift across the heavens. Maybe you can pick out a planet, a steady point of light that doesn't twinkle as much as the surrounding stars. Maybe you recognize Orion, or the curve of the Milky Way, or a faint smudge that might be a distant galaxy. You tilt your head back, and for a moment you let yourself forget about orbits and models and spectra. You just look. Somewhere far above, 3i Atlas is already growing fainter. Its passing will not leave a visible trail you can point to. It won't be the kind of thing you can show a friend years from now. Remember when that interstellar visitor went by? It was right there. By the time you tell the story, it will be gone, a memory woven into old datasets and quiet papers. But knowing it was here changes the texture of the sky. Instead of a flat ceiling punctured by distant lights, it starts to feel like depth. A three-dimensional ocean you're floating under. A place where things move, cross paths, and vanish again, carrying secrets you'll never fully know. You might picture 3i Atlas as a tiny dark shard slipping outward now, away from the sun's warmth, back into the long cold. Behind it, in its wake, is a thin invisible cloud of molecules, water fragments, dust grains, atoms that were once bound together in ice. Some of those particles will follow it forever. Others will be nudged by sunlight and gravity, drifting slowly away until they are lost in the broader haze of the solar system. Somewhere in that cloud are the very same hydroxyl radicals that left their mark on our instruments. The faint, precise pattern that first told us, there is water here, broken apart. You might imagine that line in the spectrum as a kind of spoken word, and that cloud as the breath that carried it. As you stand under the stars, your breathing begins to slow in unconscious sympathy, in and out. The world around you quiets. The distant hum of human life, traffic, voices, lights, fades, until all that's left is you and the sky, existing side by side for a while. The thought creeps in. All the atoms in your body, every beat of your heart, every breath you've ever taken, they're made from the same basic ingredients as those drifting through 3i Atlas. Carbon, oxygen, hydrogen, nitrogen, trace elements forged in ancient stars. The universe is not something you're just looking at. It is something you're made of. The visitor between the stars and the observer under the sky are built from the same story, written at different times, in different places, but with the same alphabet of atoms. The hydroxyl radical glowing in radio light and the water in your cells are cousins, separated by distance but not by law. As that realization settles in, the universe stops feeling like an out there and becomes something you're inside. The galaxy is not a stage on which you are watching a play. It's an ocean you're already swimming in, whether you notice it or not. You might feel very small under that sky, a brief flicker in a vast ancient darkness. But there's another way to look at it, like a single note in a symphony, small on its own, essential as part of the whole. Somewhere 3i Atlas continues whispering in its own quiet way, its chemistry playing out in a remote corner of space. Elsewhere around other suns, other comets may be outgassing, other fragments may be drifting, other civilizations, if they exist, may be staring up at their own night skies, wondering similar things. You and they, if they are there, are all folded into the same night. After a while, your eyes adjust more deeply to the dark. Fainter stars appear, like hidden thoughts surfacing. The longer you look, the more you see, not because the sky is changing, but because you are. Thoughts about 3i Atlas begin to blur gently at the edges. The specific details, the signal, the anomalies, the coordinates, become less sharp. What stays with you is the feeling that you live in a universe that is still surprising us, still sending us visitors and puzzles and quiet wonders, long after we thought we had mapped the basics. You feel a kind of soft gratitude for that. Gratitude that the universe is not a finished book but an ongoing story. Gratitude that we are alive at a time when instruments are sensitive enough to catch a fleeting interstellar whisper. Gratitude that we can sit under the sky, thousands of years after people first told stories about these same stars, and now tell new stories about interstellar objects, about radio signals, about the way water breaks apart under starlight. Eventually, your body reminds you that it is late. Your eyelids feel heavy. The chill of the night, or the gentle warmth of your room if you're watching from inside, begins to wrap itself around you like a blanket. The galaxy doesn't mind if you drift off. It has been here before you, and it will be here after you. It can hold the questions for a while. You take one last look at the sky, or at the imagined sky behind your closed eyes, and trace, in your mind, the invisible path of 3i Atlas, moving away now, returning to the immense in-between. A visitor has come and gone. The mystery remains, and somehow that feels peaceful. And so, somewhere out there beyond the edge of our sight, 3i Atlas keeps travelling, carrying its silent archive of ice and dust into the deep dark again. Down here, all we have are a handful of observations, a strange radio line, some stubborn anomalies, and the feeling that we've just glimpsed the universe turning a new page in front of us. Maybe, years from now, we'll look back on this and say, that was the moment we first realised how often interstellar visitors pass through. Or, that was when we began to suspect the galaxy is more connected than we ever dared imagine. Or maybe we'll simply remember it as the night an anonymous piece of cosmic debris made us stop and stare a little longer at the sky. Whatever the final explanation turns out to be, this much is already true. The universe is less quiet, less empty, and less separate than it once seemed. Wherever you are, whatever time it is as you listen, you're part of this story now too. A small, bright awareness on a small, bright planet turning gently under an interstellar sky. Let the question stay open. Let the mystery do its work. And when you're ready, close your eyes and drift, knowing that above you, between the stars, the cosmos is still moving, still whispering, still sending travellers past our door.